All right, one of the things we'll need to do in this class in a lot of different contexts is to simplify square roots. And we'll also learn how to simplify other kinds of roots besides square roots like cube roots or fourth roots. But let's start with square roots because those are the basics that we'll need at the start. So the rules for square roots are if you have a pair of like factors underneath the square root, you can simplify it. More on that in a second. If you're multiplying or dividing square roots, outside goes with outside and inside goes with inside. Again, we'll do an example of that in a minute. And when you're adding and subtracting, you have to have like terms, and we're going to explain that as well. All right, so let's start. I'm going to go explain these things by going through a few of the examples from this section of the summer work. So let's start with number 71. We have the square root of x cubed here. So what I'm going to do is I'm going to take x cubed and I'm going to factor it fully. I'm going to break it down into what it multiplies. So x cubed is x times x times x. Now, square roots. The square root of 4 is 2, right? And that's because 4 is 2 times 2. We have a pair of like factors. The square root of 9 is 3. And that's because 9 is 3 times 3. We have a pair of factors. 3 comes out. So anytime you have a pair of like factors underneath the square root, you can pull one of those things out in front of the radical and simplify. So here we have a pair of x's. That would be x squared, right? The square root of x squared comes out as x. And then whatever doesn't have a pair of like factors, it stays on the inside like that. Now, there's one little subtle thing whenever you're pulling a variable out of a square root, and we'll talk more about this in class, so it's not so important that you have it now, but I want you to see it, is that this square root symbol means the main square root, the positive square root. So whenever we pull a variable out, we have to make sure that we put an absolute value around it because it could be positive or negative. Now, if I looked at a problem like number 70, square root of 8, that's 2 times 2 times 2. There's a pair of 2's in there. I could pull that 2 out. There's still a 2 left underneath. So that would be 2 square root of 2. So let's look at number 73. 216 and r squared. Now, you don't have to break down a number all the way down to its prime factors unless you want to. I happen to know that 216 is 6 times 6 times 6. And then r squared is r times r. Now, if you broke all that down all the way into 2, 2, 2, 3, 3, 3, that's fine. But I've got a pair of 6's here, and that means I can pull a 6 out, and I have a pair of r's, so I can pull an r out. There's a 6 left behind, which doesn't have any pairs of like factors in it. It's 2 and 3, so that stays. And then I pulled an r out variable, so it needs absolute value. 75, similarly done. I've got a 4 there, which is 2 and 2. I've got x cubed, so there's 3 x's. Y to the 4th, which is 4 y's. And again, you could do this in your head. I'm just doing it to show how the process goes. Now, there's a y squared because I had 2 pairs of y's, right? Y, so I pulled out a y and another y. And there's an x left behind. And absolute values around any variables. Now, technically, the y squared we know will be positive. If you put an absolute value around it, it's fine. But the only thing that really needs it is the x. So let's look at 77. We're multiplying 2 radicals together here. We have 2 ways of approaching this. One way is to go ahead and multiply the inside times the inside on this radical. That would give me the square root of 80. And then I could do the process that I was just doing to break this down more. That happens to be 4 times 4 times 5. So that would be 4 square roots of 5. Or I could simplify each radical first. 8 is 2 times 2 times 2. So a pair of 2's, that's 2 root 2. Sorry. And then square root of 10 is 2 times 5. So that doesn't really simplify anymore. Now, when I multiply these together, 2 times this outside number gets multiplied by the 1 that's sitting out here. And then 2 times 10 on the inside is 20. And then 20 is 2 times 2 times 5. Sorry, stumbling over my words there. So I can pull a 2 out, and that gets multiplied by the 2 that's sitting out in front. Now, in this case, the simplify then multiply thing was harder than just multiplying at first, but if the numbers were really big under the radicals, it might be better to simplify first. And now let's look at number 79. So the rule with adding and subtracting is that you have to have like terms. And what I mean by like terms is that the radicals that you have, the square roots that you have, all have the same number underneath them. Now, in this case, we have square root of 32, square root of 18, square root of 2. None of those are the same, right? So you might think you can't add those, but remember, we can simplify these radicals. So if I start with 32, 32, 4 times 4 times 2, so that pair of 4s would come out as 4 square root of 2. 18, we have a 3 on the outside, and that's 3 times 3 times 2. Pair of 3s, so I can pull the 3 out, and that would get multiplied by the 3 that's already sitting there. And then the square root of 2 doesn't simplify any further. So now you see all my radicals have the same number underneath them, right? So I have 4 of these square root 2's, 9 of these square root 2's, and another 1 of these square root 2's. So when I put those all together, I have 14 of these square root 2's. It's kind of like if you add 4x, 9x, and 1x, it's 14x. The name stays the same, you just add the coefficients. Same thing happens here. So again, simplify square roots by looking for pairs of like factors. When you're multiplying and dividing, you multiply outside times outside, inside times inside. You can simplify first or simplify after. And adding and subtracting, you need like terms, but you need to simplify before you stop.